Day 3. A right angle triangle has hypotenuse measuring 10 cm. The perpendicular to the hypotenuse measures 8 cm. Find the area. This sum was one of the questions given in the worksheet on right angle triangles and Pythagoras theorem to a student of grade 7. The entire class was given the worksheet and she came to me with this particular worksheet because I wanted to have a look at it and I saw this question. Because this was a very straightforward question wherein you could apply the area formula directly, which is half into base into height, all the students in the class came up with the answer of 40 centimeter square and this was the relevant diagram. Now, when I saw the question, I realized that this question was completely wrong because this particular right angle triangle cannot be formed using the given measures. Now, it is not possible for me to tell a 7th grader and make the student understand the mistake in the question. So what I did was that I gave this particular question with a slight change to my 9th and the 10th graders. This is how I changed the question and gave it to my 10th graders. A right angle triangle has hypotenuse of measuring 10 centimeters. The perpendicular to the hypotenuse measures 8 centimeters. State by at least 2 methods why the area cannot be found. Now let us see why the area cannot be found and what are the 2 methods that can be used in order to prove this. In this particular diagram, I have marked one additional point which is x. X is the midpoint of the hypotenuse, or I can say x is the circumcenter. If you are familiar with geometry, you know that in a right angle triangle, circumcenter is the midpoint of the hypotenuse. Now I have turned the triangle in this way so that AC comes over here. Now this value of AC is equal to 10 centimeters. This is our altitude from B to AC, which is 8. Now x is a circumcenter, which means that x is the center of the circumcircle. So if I am keeping this as the center, I am constructing a circle around this particular triangle. It will touch every single vertex of the triangle. Okay. Now from X up to C, what is the distance? It is 5 centimeters. This is the radius. This radius is going to remain the same whichever point we are taking. Correct? Now, have a look at this particular triangle XBD, which is this triangle. In this XBD, what can you say about the sides? XB is our radius, BD is the altitude which is given in the question, and XD is the base of the triangle, and this angle is 90 degree, which means that in this particular triangle of XBD, XB becomes the hypotenuse. That is the longest value. XB is longer than DB, which means that 5 centimeter is bigger than DB. DB is 8 is not possible at all in this particular diagram. Let's look at the second method. As you can see, I have marked the value of x and 10 minus x as the values of hypotenuse. Hypotenuse is divided at the point D as x and 10 minus x. If you are familiar with the similarity of triangles, you know that the perpendicular to the hypotenuse divides the right triangle into two similar triangles. So I have taken the similarity concept over here. So we know that ADB is similar to BDC. I have written the measure ratios of the corresponding sides. AD by BD is equal to AB by BC is equal to DB by DC. And wherever possible, I have inserted the values. So you can see on the left hand side, x by 8 is equal to AB by BC. I do not know the measure of AB as well as BC, but I know the measure of DB and DC, that is equal to 8 by 10 minus x. I get a similarity where x by 8 is equal to 8 by 10 minus x. Now let us solve for x. So I have tried to solve for x by cross multiplying. I am getting a quadratic equation which I have tried to solve by using the quadratic formula of minus b plus or minus root of b square minus 4ac by 2a. But you can see that the circled part, it's a value inside the square root, will end up to be a negative value, which means that I cannot find a satisfactory value for x in the real domain. So it means that The measure of the hypotenuse and the altitude given is not possible for us to construct a triangle using those measures.